In question 10.1a, we are being asked to find the test hypothesis and find the p-value. To test the null hypothesis where mu1 is equal to mu2 against the alternative hypothesis where mu1 is not equal to mu2 with known variances, we use the z-sample test. Here is the formula for the z-sample, and then we have all the datas, and then we input all the datas here, and we find the z-sample to be like minus 0.972. This is a two-tail test. We need to find the probability of observing a z value less than minus 0.9072, and the probability of z value greater than 0.972. I'm sorry. So we go to the table and find the p-value. Here we look for the p-value less than 0.9072, which is going to give us approximately 0.1812, and then p-value where z is greater than 0.9072 is going to give us the same data as the previous one. We can use the double smaller probability, one of them, and then we multiply it to give us the p-value. Here the p-value is going to be 2 times 0.1824, which is going to give us 0.3624. Hence the p-value for the hypothesis is approximately 0.3624. In question 10.3a, we are being asked also the same to test the hypothesis and find the p-value. To test the null hypothesis, which is mu1 is equal to mu2 against the alternative hypothesis where mu1 is not greater than mu2. We can use the two-sample z-test since we have the known variances. The z-sample here, and then these are the data we have been given. If we compute all the data into the formula, we are going to get the z to be like 0.938. Now we need to find the p-value since the alternative hypothesis is one-sided and the p-value is observing a test statistic as extreme as 0.938 or greater, assuming null hypothesis is true. To find the p-value, we can use a standard normal distribution table. Using the table, the p-value, let's say the z we got here is 0.938, we can be found in the table, which I looked into the table and then I found like the p-value is going to be 0.1736. Since the p-value is greater than the significance level which we have of 0.01, we fail to reject the null hypothesis. Hence, based on the given data, there is not enough evidence to conclude that mu1 is greater than mu2 at 0.01 significance level. Thank you for your patience.